Hello, start. Continue.
Yeah, screen is visible.
Yes, it is visible.
The question that I had left in last class. See, I'll just tell you one thing. If anyone has not seen the previous 3 classes, then you'll find it will be very difficult for you to follow. Okay. So if you're attending this class, just ensure that you have attended till the last class. Okay. Or at least watch the recording. Okay. So what the question I just left it half last class is that find the condition that ABC belongs to the span of 112, 233 and 135. So this question we'll complete it today. So what I'm doing, I'm writing all the vectors as rows of a matrix. I'm writing like this. And fourth row I'm writing as ABC. Okay. And I'm also writing another matrix here. I'm writing this row, I'm giving name V1. This row I'm giving name V2, U2, and this I'm giving name U3, this is U1, sorry. And this row I'm giving name as B, okay. Now my aim is I will reduce this matrix into row echelon format, and whatever operation I'm doing here, I'll do side by side here, okay. You'll understand when I'm doing, don't worry. As I do, you'll understand. So what I'm doing. Now how to reduce to row echelon form? Tell me. This you will do. This is you will keep as pivot. Keeping this as pivot. What I'm doing? What I'm doing? Row 2 implies row 2 minus 2 row 1. I am doing row 3 implies row 3 minus row 1, and I am doing row 4 implies row 4 minus a times row 1. Okay. So now I can do 1 1 1 1 1 2. This will be 0 1 and minus 1. This will be 0 2 and 3. This will be 0 b minus a and c minus 2a. Clear? And whatever operation performing here, you also perform here. Okay. So I'm having u1, I'm writing u2 minus 2 u1, I'm writing u3 minus u1, I'm writing b minus a into u1. Okay. So next I'm keeping this as pivot. Okay. I'm keeping this as pivot, and I'm going to perform operations. But before I perform operations, I'll multiply. I can perform that, not required. I can keep this as pivot. So what I can do? From row operation I can perform row 3 implies row 3 minus 2 row 2, and I can do row 4 implies row 4 plus a minus b into row 2. If you perform these operations, then you will get 0, correct? You will get 1 1 2 0 1 minus 1 0 0, then 5, and you will get 0 0. For this element I'll write c minus 2a plus I'm multiplying this by a minus b, so it will become b minus a, right, plus b minus a. So this I can simplify as c plus b minus 3a. C plus b minus 3a. Okay. Here I'm writing u1, u2 minus 2 u1. Now listen carefully what I'm doing. I'm doing row 3 implies row 3 minus 2 row 2. Listen carefully. I'll multiply this by minus 2. This is rough column. I'm writing minus 2 u2 plus 4 u1. I'm keeping row 3 as such. And this sum I'm writing here. Writing sum here. What will be the sum? It will be u3 minus 2 u2 plus 3 u1. Okay. Similarly, I'm multiplying row 4. I'm keeping constant. Okay. And I'm multiplying row 2 by a minus b. I'm writing a minus b into u2 plus I'll write 2b minus 2a into u1. Okay. And now I'm adding both of this and I'm writing it here. If I'm doing what will I get? I'll get v minus u1, what will I get? Minus a, v plus 2b minus 3a into u1 plus a minus b into u2. This is clear? So finally, I'm taking this as pivot. I'm taking this as pivot. Then I can get. First, what I'll do, I will multiply this by 5. Doing 2 row operations. I'm multiplying. Do cross multiplication. Multiply this by 5. Multiply this by c plus b minus 3a. So I'll write away row 3 implies row 3 c plus b minus 3a times row 3, and row 4 you multiply by 5. Row 4 implies 5 row 4. So I'll do these operations. What I'll get? I'll get 1 1 2 0 1 1 2. I'll get 0 1 minus 1. Then I'll get 0 0 5 into c plus b minus 3a. Here I'll get 0 0 5 into C plus B minus 3A. Here I'll be getting U1, then I'll get U2 minus 2U1, then I'll be getting U3 minus 2U2 plus 3U1 into this entire quantity C plus B minus 3A, and this here I'll be getting B plus 2B minus A into 2B minus 3A into U1 plus A minus B into U2 whole multiplied by 5. I'm not doing 5 everywhere. So this is clear. Now final I'll apply the row operation. Little hectic sum only, I'm understanding. It's very but this is how the questions will be. I have to just tolerate it. Okay. So I'll write row 4 implies row 4 minus row 3. So now if you are doing the final operation, you get 1, 1, 2, 0, 1 minus 1, 0, 0, 5 into C plus B minus 3A, 0, 0, last row will get 0. Okay. So here you will do U1, U2 minus 2 U1, will get U3 minus 2 U2 plus 3 U1 into C plus B minus 3A, and here you will do this big thing minus this big thing, that is this you will write here, and this you will write here. You will subtract it. Okay, I'm not doing it, it will take a lot of time. And if you're observing carefully, what is the rank of this matrix? Can someone tell me what is the rank of this matrix? Can someone tell me what is the rank of this matrix which I wrote? 3, because there are 3 non-zeros, correct? So can I say that dimension of the space is 3? Okay, that is dimension of this is 3, correct? Now if you observe carefully, am I getting any condition for ABC? See, listen carefully. This is the notes of last class. Last class we did this question. Okay, find the condition that this vector belongs to span of this. Here we didn't directly get 0. Look at this. Here we didn't directly get 0. We wrote 4A minus 2A plus 3C. We imposed condition on it. We made it 0, and then we said we said this is the condition that is required. We want last two 0. We imposed the condition. Okay, but if you see today's question, without imposing any condition, last row became 0, meaning A, B, C belong to span. That is, what is span? R cube, irrespective of any condition. Is it clear? Because always, if writing A, B, C, always it belongs to R cube. You don't need any condition. No, A can be anything. This can be anything. This can be anything. This can be anything. Whatever value you give, it will belong to the span. All these concepts only if you have 100% clarity, you have attended previous classes, you will be able to understand. Okay. And how you let linear combination? You will subtract this and you will equate it to this. You will equate to 0. This will be equate to 0. Then you will get V in terms of U1, U2, U3. Okay. This you will do on your own. Okay. Not going to waste time. I'll write it and I'll post it anyway. Okay. Now, definitely, I am aware of the fact that many people are, what is this? They are very, you are very scared of this. So what I decided is today, ma'am has given assignment. Okay. So I decided that we will do the assignment questions, and with that we will be very clear with the concept. Okay. So I'm going to do assignment questions. You can even note down. Okay. Because exact same question I'm doing. Okay. So don't worry. We'll do the question. And now after this, if you don't understand the concept, then we will think of what to do next. Okay. So linear combinations of vectors. This is the heading. And this is question number 5. Question number 5 of 5 in assignment. Okay. Writing question number in assignment also. We'll be doing the questions in the assignment. Okay. So look at first question. First question they are saying express 1 minus 2 5 as a linear combination of 1 1 1 1 2 3 and minus 2 minus 1 1. Okay, this is a question that is there in the assignment. We'll try to understand how to do this question, and it will be very simple. Okay, look at this carefully. What I'm doing is I'll keep this vector as V vector. I'll keep this as U1. I'll keep this as U2. I'll keep this as U3. Now what I'll do is I'll write a matrix 1. I'll write 1 1 1 1 2 3 2 minus 1 1 1 minus 2 5. This will be equal to U1 U2 U3 V. Correct or not? Now look at this carefully. Now same thing what you do again you are doing. What you are doing, you are trying to reduce to row echelon format. So I am performing the operations. Row 2 implies row 2 minus row 1. Then I'll apply row 3 implies row 3 minus 2 row 1. Row 4 implies row 4 minus row 1. So performing these operations, I will get 1 1 1 0 1 2 0 minus 3 minus 1 0 minus 3 minus 4. Okay, and whatever I told you, whatever operation you are performing in this matrix, do the same thing in this matrix. You will get one. Yes, tell me.
One doubt.
Huh?
And that U3 you have taken -2 -1 and 1, right? But here you have taken as 2 -1 1.
Oh, sorry, I copied wrongly. Sorry, question is, this is 2 only. I took a mistake. Sorry.
Okay, right.
Question is wrong. Assignment question, Nakpa. You can see assignment. Same question only I'm doing. Okay. Look at this. Clear? Whatever operation performing here, I'll perform here also. Okay. Whatever you are performing here, perform on both matrix together. You understand? It's going to be very useful. Okay. This method ma'am has not told. Okay. She performed only on one matrix. But if you are performing on both matrix together, it will be very useful. Listen carefully. I'll just write down. Perform same operations on both matrices. So after you finish the question, you will understand how much useful this method what I said is. Okay. So look at this now. Next, what I'll do? Manning this. I took this as pivot. Now I'm taking this as pivot. Correct. I'll multiply this by 3 and add this. I'll do for both. I'll do the same thing. So next row operation I'll perform is row 3 implies row 3 plus 3 R2. Row 4 implies row 4 plus 3 R2. Correct. So this will give 1 1 1 0 1 2 0 0 5 0 0 10. This will be equal to U1 U2 minus U1 U3 minus 5 U1 plus 3 U2, and you will get V minus 4 U1 plus 3 U2. Do you understand? What I'm doing is row 3 plus 3 row 2. Multiply this by 3, add with this. This you try on your own. Okay. Multiply this by 3, add with this. Multiply this by 3, add with this. That you will get here. Anyone has any confusion, you can stop me. Okay. Final step I'm doing. Final step is I'm taking this as pivot and I'm performing operation row 4 implies row 4 minus 2 R3. If I'm doing this operation, then I'll get 1 1 1 0 1 2 0 0 5 0 0 0. This will be equal to U1 U2 minus U1 U3 minus 5 U1 plus 3 U2. You will get V plus 6 U1 minus 3 U2 minus 2 U3. Now tell me someone, is it reduced in, is it in row echelon form? This one? Can someone confirm, is it in row echelon form?
Yes.
Tell me. And what is the rank of the matrix?
3.
3, correct. Which means that last row is waste, right? Meaning if the last row I can say row 4 is a 0 row. So can I say this thing, look at this carefully, can I say this thing is going to be 0? So can I say V plus 6 U1 minus 3 U2 minus 2 U3, can I say it's 0? So can I say V will be minus 6 U1 plus 3 U2 plus 2 U3. That's it. The question asked was express this as a linear combination of these 3. That's what I have finished the work. Look, this is a linear combination. V as a linear combination of U1, U2, U3. That's it. Work over it. Does anyone have any problem in any of the steps? Please ask. I will tell you. Please tell me. I will proceed to next question for understanding everything. Tell me. Clear? So why now you understood what is the use of doing this operation, this matrix also. If you're doing only on one matrix, then this matrix, if you're also doing together, then this relation you can get this as 0. Directly you will get linear combination also. That's the use of doing on both together. Any doubt? Anyone else? Can I proceed next question? It is Gautam. Just one more. What I want to follow? Just one of you tell. Can I proceed?
We can proceed.
This is easy, right? So second question in assignment 5.2, they are saying, if possible, express V vector I'm giving 2 minus 5, 3 as a linear combination of giving you 1 minus 3, 2. Keep this as u1. u2 you are keeping as 2 minus 4 minus 1, and u3 you are keeping as 1 minus 5 and 7. Okay. Possible try to express. You also keep doing independently. Then finally we can check the answers. Okay. So what I am doing? So I am writing 1 minus 3, 2, 2 minus 4 minus 1, 1 minus 5, 7, 2 minus 5, 3. Okay. This I am keeping as u1, u2, u3 and v. Okay. u1, u2, u3 and v I am keeping. 1 minute. Okay. Now what I am doing? I am keeping this as pivot. Same thing again I am doing, but for different purposes. Here I am trying to express as linear combination. We found rank. So many things I have done with the same method. R2 implies R2 minus 2 R1. R3 implies R3 minus R1. R4 implies R4 minus 2 R1. Right. So what we can say? 1 minus 3, 2. Then we can get 0, 2, 5. I have written down on keep. That's why I am doing fast. So you know it's not a problem. It will be equal to u1, u2 minus 2 u1, u3 minus u1, v minus 2 u1. Okay. Next, what's the step? I'll multiply this row by 2. Okay. I'll multiply this row by 2 so that you can apply row operation faster. What I'm doing? I'm doing row 4 implies 2 row 4. Okay. So 1 minus 3, 2, 0, 2, 5, 0 minus 2, 5, 0, 2 minus 2. This will be equal to u1, u2 minus 2 u1, u3 minus u1, 2v minus 4 u1. Correct. Next, what operation I'm performing? I'm keeping which as pivot? I am keeping 1 minute. Yeah, I'm keeping this as pivot, right? I'm keeping this as pivot, and then I'll be performing row 3 implies row 3 plus row 2.
Prajwal, second row,
Yes.
third element on the minus 5. Second row, third element after transformation.
Second row, third. Okay. Yes. Thank you. Minus. Yeah. Minus. I copied wrong. Yeah. Minus. Thank you. So you're having, and you'll write row 4 implies row 4 minus row 2. Then this will become 0. Look at this carefully. What is happening? So you will get 1 minus 3, 2, 0, 2 minus 5. You'll get 0, 0, 0. You'll get 0, 0, 3. This will be equal to u1, u2 minus 2 u1, u3 minus 3 u1 plus u2, 2v minus 2 u1 minus u2. Okay. Any confusion till now? See, whatever operation I'm performing this side, I'm performing this side also. Okay, that's the end of this. That's the moral. Whatever you do here also. Okay. Now observe carefully. R3 is a 0 row. Okay. So I can say u3 minus u3 u1 plus u2 equal to 0. So I can write u3, I can write as 3 u1 minus u2. Okay. Meaning this is a waste vector for us. Because whatever work, see, we are taking these 3 vectors. We are taking these 3 vectors as a reference. Understand? We are taking these 3 vectors as our reference. But I told you that when you are taking a reference, don't take waste vector. See, this vector you can write 3 1. So why do you want to take u3? Whatever work u3 is doing, these two are doing together. So it's the waste vector. So what we are doing is, because the waste vector, they are eliminating it from our column. We are eliminating this completely. So what we do now? You are writing 1 minus 3 2, 0 2 minus 5, 0 0 3. This will be u1, u2 minus 2 u1, 2v minus 2 u1 minus u2. Okay, you understand? So do this carefully. Can I say this in row echelon form? Yes, row echelon form. Can I say rank is 3? Is a rank is 3? Can I say? Listen carefully.
No.
Rank will be number of independent vectors. Number of linearly independent vectors. So just please think for a moment. If I am telling you these 3 rows are independent, can I say u1, u2 and v are linearly independent because there are 3 vectors, right? If I am saying these 3 are linearly independent, can I write v as linear combination of 1 and 2? Is it possible? Is it possible? Tell me. Can I write u1? Can I write v as linear combination of u1 and u2 if they are linearly independent? Someone tell me. Is it possible?
Oh, we
Hmm?
can't. We can't.
We can't because they only the dependent you can write. No, they're really independent. How you write? And U3 is waste. U3 is dependent on this too, so you don't even have to talk about it. Only U1, U2 will talk about. And it's linear independent, because rank is 3, row echelon form 3. So obviously it's not possible. Okay, so conclusion is we cannot be expressed as linear combination of U1, U2, U3. That's it. This is the conclusion. Okay. Last question we got the answer, but this question, see, if you observe carefully, you want to make this 0, I mean this should be 0, right? Can this be 0? This element, can it ever be 0? Can never 0, correct? So if this is not 0, this is not even 0 row. How can I make this 0? It's not possible, right? It's not possible. So you can never express P as linear combination of U1, U2. The same concept. Now, if you want to do geometrical understanding, listen carefully. If you take U1, U2 alone, what is rank of this matrix alone? Listen carefully. Do you understand what I'm saying? Suppose you are taking only first 2 rows. I'll say rank is 2. Get out on that. So can I say dimension of, suppose I'm taking U1, U2, this will be 2. I mean, this is the plane. If you want to understand this geometrically, look at this carefully. You're having a plane, and you're having 2 vectors on the plane, something like this. You're having U1 and you're having U2. U3 is on the plane itself. U3 is somewhere here. But W vector is something like this. This is the plane. W vector is out of plane. So if it's out of the plane, then how can it be dependent on this? If W is out of plane, then how can it be dependent on U1, U2? It's not possible, right? Any vector on the plane, you can write some combination of these two. If it's out of the plane, how you can write? You can't write it. Understand? This is geometrical interpretation. Anyone has any doubt? Please ask. Can I go to the next question? Write some theory also. W is not situated on the subspace span. All these technical terms you should understand. Subspace span, which is a plane spanned by U1 and U2. As a result, W cannot be written as a linear combination of U1 and U2. U3 is redundant. Any doubt on this? Can I proceed? Next question, can I proceed?
Okay, we can proceed.
Okay. Look, third question. Third question will be, please try this. We express, now we are going to do matrices, okay? Express 3, 1, 1 minus 1 as a linear combination of 1, 1, 1, 0, 0, 0, 1, 1 and 0, 2, 0, minus 1, okay? This will be matrix M. I'll keep this as M. I'll keep this as A. I'll keep this as B. I'll keep this as C, okay? So we have to try to write this as a, we'll see whether we can write as linear combination or not, whatever, okay? Listen carefully. But now, till now we discussed only n tuples, correct? We only saw n tuples like this, see? Where is it? Question. We only got n tuples, correct? But suddenly, instead of n tuples, we are getting matrices, correct? Now, whenever you get, I like this rule, whenever an entity other than n tuple appears, convert the entity into an n tuple. Do this carefully. Can I write, suppose I'm having A, B, C, D, I can write this matrix in n tuple format like this. Are you agreeing with me? This is matrix format. And this I can say n tuple format. Any doubt anyone is having? Tell me, is this clear? Whatever you are having, convert it into n tuple. Question solved. So now what I'll do is, now I'll write 3 1 1 minus 1. No, sorry, first I'll write this 1 1 1 0 0 0 1 1 0 2 0 minus 1 3 1 1 minus 1. Any doubt in this? This will be A B C M. Any doubt in anything? Please tell me. Not as doubt. We'll discuss about this more. Whatever matrix they are giving, we'll see one more example in ma'am's sheet. Whatever they are giving, convert it to n tuple, because only n tuple you can write as one row. Okay. Otherwise, you will definitely face problems. Please convert to n tuple and proceed. That's the best method. Okay. So now from performing row operations, I'll be performing written all the operations, just writing. I'll be performing row 4 implies row 4 minus 3 R1. So I'm performing this operation, I'll get 1 1 1 0 0 0 1 1 0 2 0 minus 1 0 minus 2 minus 2 minus 1. This will be equal to A B C M minus 3A. Look at this carefully. Initially, I am taking this as pivot, right? I'm taking this as pivot. But here, there is no pivot, right? This is no pivot. So what I'll do, but this can behave like pivot. So what I'm doing, I'm exchanging. Do row exchange. Because we need pivots. Without pivots, we cannot do anything. Pivots is a non-zero number, remember that. So I'm doing row 2 interchange row 3. That is, I'm doing interchange. And what will I get? I will get 1 1 1 0 0 2 0 minus 1 0 0 1 1 0 minus 2 minus 2 minus 1. This will be equal to A C B M minus 3A. Okay. Now I'm going to perform row operation. Now I can take, now see I'm having pivot here. Now I can take this pivot and do. So what I'm doing? I'm doing row 4 implies row 4 plus row 2. I'm doing this operation. I'll get 1 1 1 0 0 2 0 minus 1 0 0 1 1 0 0 minus 2 minus 2. This will be equal to A C B M minus 3A plus C. M minus 3A, and this you are adding plus C. Okay. Then I am performing. What else I can perform? Yeah, now I can take this as pivot. And I can perform the final row operation. Row 4 implies row 4 plus 2 times row 3. In performing this operation, I will be getting 1 1 1 0 0 2 0 minus 1 0 0 1 1 0 0 0 0. That's it. I'll get A C B M minus 3A plus 2B plus C. I can say this is 0 row. I can say this is 0 row. So I can say this also should be 0. So I can say M I can write as 3A minus 2B minus C. That's it. I have expressed the given matrix as a linear combination of given 3 matrices. This is the method of reducing into row echelon form. Side by side you are writing this matrix, and side by side you will get the relation also. And this rank is 3, meaning there are 3 linear independent matrices. That's it. Okay. Any sort of confusion, any step, please ask. Is there any sort of confusion, any step?
So examல நம்ம இதே மாதிரி பண்ணலாம்ல? Like matrix எடுத்துட்டாங்கன்னா வந்து
Actually, I asked ma'am. I sent a question to her. I asked, can we use this method, and she has accepted. Okay, you can do this method.
Oh.
Ma'am gave method. You will write as K1A plus K2B plus K3. See that one, ma'am gave. Ma'am
okay.
gave method. But see, you can.
Matrices.
Yeah, you are doing 2 works at one time, right? You're also checking whether they're independent. They are dependent. See, you don't know whether you can write or not. The question is, if possible, okay. If possible, everywhere if possible, I didn't write. Okay, if possible only. See here, you're doing 2 work at one time. You're checking whether it's possible. Same time, you're trying to get relation. You're doing என்ன தமிழ்ல சொல்லுவாங்க ஒரு கல்ல ரெண்டு மாங்க அது மாதிரி இது. Any Tamil you can understand. I don't know. I mean, I don't know how to tell English. Okay. One stone you will throw and you will get 2 mangoes. So something like that, right? you're doing one work, you're doing two different outputs, two different works you're getting. See, you got the 3 linear independent matrices, same time you're getting relation. Okay, so it's good, right? Why do you want to do 2 works for 2 outputs? ஒரு கலர் ரெண்டு மாங்க எடுத்துருங்க பெஸ்ட். கரெக்ட். Sheet format. Okay, can I go to the next question?
Yes.
So yeah, I'll do only one more question. Okay. This question number 7 in sheet. This I will type in assignment. Question number 7. It will be, let W be the 4 generated vectors, and write here vectors will be -2, 5, -3. I will write 3, 1, 4, and I'll write 3, 8, 3, -3, -5. Okay. Question asked is, find a basis and dimension. The basis of the fixing the basis to span the whole R4. Okay, look at this very carefully. We're having R power 4. R power 4 means you are having 4D space. Okay, in 4D space, if you want to have span, you need to have look at this. If you remember in the last class, you see conditions for vectors to form bases. You need number of linear independent vectors to form dimension of span. Meaning, if you want to have some basis for this, you need to have 4 vectors. But here only 3 vectors are there, which means given vectors do not span whole R power 4. Instead, they span a particular subspace of R power 4. Okay, the question they're asking is, find the dimension of that subspace. Okay, find the dimension of subspace. How you will do is, just write the matrices like this, 2, 3, same thing again you will do. Okay, this row echelon format, avlo practice you will get, because so many models same thing are doing again you are doing same thing. That is row echelon form. So I will do row 2 implies row 2 -2 row 1, and I'll get row 3 implies row 3 -3 row 1. So someone can help me? I don't think I've written this down. Someone help me now. 1 -2, 5 -3. This will be 0. This will be what? 7. This will be -9. This will be what? 10. Correct? But I know. This will be 0. This will be, what will this be? 6 plus 8, 14. This will be -18, and this will be 9 - 5, 4. Kata? Yeah. The next, what you're doing, you took this as pivot initially. Now you are taking this as pivot, correct? And what you can do, you can perform operation. What you can perform, you can do, tell me, someone tell me the operation. Always I am telling.
R3s, R3 - 2, R2.
That's it, simple. You want to make this 0, that's it. So logic, 1 -2, 5 -3, 0, 7 -9, 10. This will be 0, 0, 0, 0. Oh no, it's not 0, it's not coming 0. I thought it will come 0. What is this? Into -2, -20 plus 4, -16. Correct? That is the correct answer, right? This is correct, right? Someone check. Square Nopper. Square I know. Yeah. This is row echelon format. We got it. So in row echelon format, what is rank? Rank we can get as 3, correct?
3.
Getting rank as 3. If I'm getting rank as 3, I can say rank of matrix
Dimensions.
is 3. So I can say dimension of the subspace, dimension of W will also be 3. Meaning dimension of W will be 3. Okay. Meaning this is a 4D. Listen carefully. Try to understand. This is 4D region. In 4D region, W is one specific 3D region. See, don't try to visualize. You cannot visualize. We don't have the strength and power to visualize 4D. Okay. We humans. We are only limited to 3D. Okay. So don't try to visualize 4D. Or trying to visualize. Don't. Okay. W one specific 3D region in it. Okay. Now they're asking you find the basis of the subspace. Listen carefully. Find the basis of W. Okay. How to find basis of W? Basis means I want basis of subspace. Meaning I know the dimension of the basis is 3. Now dimension of subspace, I can say it is 3. So I can say number of linearly independent vectors in basis of subspace, it will be 3. Right or not? And what are the 3? Listen carefully. It is your choice. You can take these 3, or you can take these 3. You can take these 3. You can take anything. Okay. Yeah, all these are linearly independent. Correct. If you are doing row operation, rank is not going to change. Listen carefully. I tell you one thing. This is rank 3. For this also you'll have rank 3 only. For this also you'll have rank 3 only. Okay. So any set of 3 vectors you can take. Generally we can take anything. I'm not generally nothing. You can take anything. You can take this 3. What is question? What is given? So you can take, or you can take this also. Okay. Anything. I'll just take what is the question. Okay. Since I can say basis of W, I am taking as what? 1 minus 2, 5 minus 3. 2, 3, 1, 4, 3, 8, minus 3, minus 5. I am taking this itself, okay? Because anyway, there are 3 independent vectors, right? To find basis, I need 3. I need as many number of independent vectors as is the dimension. Correct? So I have 3. Dimension 3 is 3. Okay. So this now, so I have found dimension of W is found. This is found. Now next we are telling one more thing. Extend the basis to span whole vector space of R bar. Do this carefully. Try to understand carefully. We are having 4D region and subspace is only covering one specific 3D region. But now I am telling this is the basis I am giving. You extend this basis such that it covers 4D fully. Meaning I have to so I need to listen carefully. I am having W1. I am having W. I will add one vector. I'll write like this. I am having basis of W. In this I am adding one linear independent vector. I can't add dependent vector. Okay. I'm adding add plus one linear independent vector. And this had dimension 3. Now this will become dimension 4, correct? Any doubt in this? This will become whole R per 4. Any doubt in this? This equation you should be 100% clear. Try to understand what I exactly done. You're having W, basically getting 3 vectors. This is dimension 3. Now if I'm adding one linear independent vector inside this will become dimension 4. This will span whole vector space. Any doubt in this? Tell me. First tell me if you're clear with this. If you're not clear, you can't proceed, right?
Yes.
You need to be very clear with this logic. Can I proceed, Pa?
Yeah, proceed.
So now my task is, see, I need to add one vector into this, but I need to be very careful that I listen carefully. Can I add 1 plus 2, 3? This if I'm adding, I get 1. I'm adding this 6, 1. Can I add this vector into this? Is it possible? Can I add this vector? Is it possible?
No.
Because if I add this vector, it's a waste vector, then. Huh? This vector, if I'm adding, it will become a waste vector. Okay, so I need to add a vector such that it is not a waste vector. So whatever you're adding, ensure it's not waste. How you will ensure not waste? Go to row echelon format. Now try to write something here which will not give you, it should not give you waste row. Okay, whatever you're adding should not give you a waste row. Listen carefully. Can I write 0, 0, 0, 1? Can I add it here? Is it possible?
Yes, we can add it there.
No, you can't add it.
We
How can you add
can.
it? Pa? If you add, this, it is waste on, now perform another row.
Okay. Oh, we can perform another operation. Okay.
So try to add something which is not waste. Okay, that's what I'm trying to tell you. Try to add anywhere you can add. To add here, will this be waste? Minus 1, 0, 1, 0, 0. Is the row echelon form getting spoiled? Wait, I'll write it here. So you need to add. So add one vector which is not a waste vector. I'll write like this, which is not a waste vector. We will do. In fact, I have not done this. I should sit and do here. So we will see this in case. So take the row echelon format. Take the final row echelon format. We're having, what is the format? Someone tell me. No. We'll get 1, minus 2, 5, minus 3. Next row, we'll have 0, 7, minus 9, 10. And you'll have 0, 0, 0, minus 16. Okay. Now if I'm adding, suppose example, if I'm adding 0, 0, 0, 0, 1, this if I'm writing here, this is a waste vector, correct? This is waste, don't add it. Now you try to add, I don't know which will be non-waste. You just try to add unit vectors like this. Okay, try to add 1, 0, 0, 0. Okay, you keep it at the top. Look at this. I'm adding this in the top. 1, minus 2, 5, minus 3, 0, 7, minus 9, 10, 0, 0, 0, minus 16. Now tell me, is it in row echelon format? Not one, we have to convert again. If you're adding any new vector, you need to again convert. You have to again convert this to row echelon format. So I'm not completing this question. Okay, I'll just complete the question and I will post it anyway. Okay, because it will take time. What you do, try to add any new vector, and when you add it, it will get disturbed. This is not row echelon format, right? Now you again need to try to convert to row echelon format. Or if you add in the, suppose I'm adding the end, what will happen? We'll see. Trying to add at the end. 1, minus 2, 5, minus 3, 0, 7, minus 9, 10, 0, 0, 0, minus 16, 1, 0, 0, 0. Yeah, anyway, if I'm adding again, everything will get disrupted. Okay, try to add this now. We'll check. Perform row operation. We'll see. 2 row 4 minus row 1. What will you get? We will get 1 minus 2, 5 minus 3, 0, 7 minus 9, 10, 0, 0, 0 minus 16, 0, 2, then minus 5, 3 kata. Then you do. Next, what do you perform? Next, you can perform this and this. I'm keeping. Work, lot of work, not a problem. So I'll do row 3, I'll do row 4, implies 7, row 4. I'm doing, what will I do? 1, minus 2, 5, minus 3, 0, 7, minus 9, 10, 0, 0, 0, minus 16, 0, 14, minus 35, 21. Correct? Someone keep checking. I'm prone to make mistakes. That's why. Everyone will make mistake in this main calculation. Full calculation. Row 4 implies row 4 minus 2, row 2. What will I get? 1, minus 2, 5, minus 3, 0, 7, minus 9, 10, 0, 0, 0, minus 16, 0, 0, multiply minus 2, minus 35 plus 18. What? Minus 35 plus 18. Minus 35 plus 18. What is it? 15 minus 8, 7, 2 minus 17. Then 15. Then minus 2, 20, become 1. Is this waste? It's not wasted. Row echelon format, this is there. Yeah, this you exchange row 3, row 4. Look at this. I'm exchanging row 3, row 4. What will I get? I'll get 1 minus 2, 5 minus 3, 1 minus 2, 5 minus 3. I'll get 0, 7 minus 9, 10, 0, 7 minus 9, 10. 0, 0 minus 17, 1. And here I'll get 0, 0, 0 minus 16. This is row echelon format. See, this is row echelon format. This is row echelon format. Meaning, what is the rank of this? 4. So I can say dimension of span, new span, can I say 4? Meaning, I can confirm, it is confirmed that 1000 is not based. So I can take span of whole vector space R power 4, you can take as these 4 vectors. Which 4 vectors? You can take 1 0 0 0, and you can take the 3 vectors given in the question. What are the vectors now in my hand? 1 minus 2 5 minus 3. This will be 2 3 1 4 and 3 8 minus 3 minus 5. These vectors will span the whole. So you are just adding one vector and you are extending it, but you have to ensure that the vector you are adding is not a waste vector. So these vectors, they span whole R power 4. Any doubt in any of the concept? Very conceptual. Nothing like, everything can be understood. Nothing like you would just memorize. Nothing like that. Everything is conceptual. Any doubt in any concept anywhere? Tell me. Only one more last question I'll do and I will close the session. Okay. So this basis, span, dimension, it is, I think, I've taken 2 classes in depth I have taken. So if you are understanding both the classes, then you will be very thorough with this concept. Can I go to last question? But also linear combination.
Okay.
Yeah, last question I'll do.
Linear combination exam irka?
Yeah.
The inner products adala irka?
Inner product is there, but see,
linear,
that's yeah, inner. I'll tell you, listen carefully. Inner product, and you are having this Gram-Schmidt orthogonalization. This is little abstract. Even I am still not clear. I have to sit and study. Anyway, if possible, let's just put YouTube video, okay? Because it's not possible for me to take any more class because the exam is in 2 days, right? Not a problem. I'll send YouTube videos, class. Not a problem. Not only I should do YouTube video. There's one question in ma'am sheet. I want to do polynomial also, okay? Express V as a linear combination. Now, please do this question. I'll give 2 minutes time, then I'll start. I want you to try this one question, okay? I just give you how to do it and then you can do it. Okay, look at this carefully. Look at this question. I am giving u1 I'm giving as t squared minus 2t plus 5. This is there in ma'am sheet. I'm not giving any my own question at all. T2 t squared minus 3t, and I'm giving u3 as t plus 3. And I'm giving vector v, they're not vector, polynomial v as t squared plus 4t minus 3. I want you to express v as a linear combination. How will you do this then? Listen carefully. What I told you, this rule you should remember. Where is the rule? Here. Whenever an entity other than n tuple appears, convert the entity into n tuple. Simple. So now tell me ideas. How can I convert this to n tuple? Can I write u1 as 1 minus 2 5? I can write like this, right? I'll just write in general. In general, let a2t squared plus a1t a0 be expressed in n tuple format as a2 a1 a0. See, it's not compulsory writing. You can also write a0 a1 a2. Okay, so don't ask to worry this order. Any order you can write. Okay, not compulsory. Any order you want to write. Okay. Now we'll do this question. You also please do independently. Don't depend on me because I've given a lot of practice. Try to do it on your own. Okay. So writing 1 minus 2 5, 2 minus 3 0, 0 1 3, 1 4 minus 3. This will be u1, u2, u3. This will be v. Okay. Tell me what. Tell me you have to tell me. I'm not written down. Tell me what row operation perform. Tell me what all row operation I should perform. Some volunteer. Some other always Gautam is volunteering. Someone is also volunteer. What row operation can I perform?
R2 is R2 minus 2 R1.
Please be a little more louder.
R2 is R2 minus 2 R1.
Very good. Next, what else? Next operation.
R3 is R3 minus R1.
No, R4, not R3.
R4, sorry.
R4 is already
Yeah,
0,
R4,
right?
R4.
Yeah, that's it. So what we'll do? 1 minus 2, 5. This will be 0. This will be 1. This will be what? This will be minus 10. This will be 0, 1, be 3. This will be 0, 6, minus 8. This will be equal to u1. The second rate u2 minus 2u1. The second rate is u3. The second rate is v minus u1. That's it. See how simple it is. Next, which is the pivot? I am keeping this as pivot and I am performing row operation. What are the operation? Just tell fast. My class has to end in another 2 minutes. So I can perform row 3 implies row 3 minus row 2, and I can write row 4 implies row 4 minus 6 row 2, right? Not like it. I will get 1 minus 2, 5, 0, 1 minus 10, 0, 0, 13, 0, 0, 52 I'll get. This is equal to u1, u2 minus 2 u1. Here you will have u3 minus 2 u2 plus u1, 2 u1. All this I written numbers. I'm doing fast. You can slowly check what I'm doing. Whatever operation I'm performing, I do it on this side. You will get it. Okay, don't worry. I'm just doing it to finish the class fast. So this what I can do. Now next operation I can keep this as pivot. Now what I'm doing, row 4 implies row for 13 4 of t2. So I'm writing row 4 minus 4 times row 3. Last operation I'm doing. So I can get what can I get? I can get 1 minus 2 5, 0 1 minus 10, 0 0 13, 0 0 0. This will be equal to u1, u2 minus 2 u1, 2 u1 minus u2 plus u3, and here you will get v, not v1, this is v, v plus 3 u1 minus 2 u2 minus 4 u3. So what I can do, I'm doing the same thing. This is 0 row. This is 0 row. So I can say this entire entity will be 0, equal to 0. You can do. You can write v as minus 3 u1 plus 2 u2 plus 4 u3. That's it. No difference. Any question. Same thing. Do again. So I can say this is linear combination. Out in this linear combinations, I have finished in depth. All sorts of concepts, all models, everything I have done. If anyone has any doubt, please ask. Okay.